Hello, everyone. Um, it is time to review this paper. It is not printing, so we're going to just use PDF. Okay. Um, and I am going to go through the NeurIPs 2026 reviewing guidelines and use the Open Review Assistant. Now, technically, I'm not supposed to share the paper with people before the reviews are due, but I think I'm going to get like 2 viewers on this, so it's like unlikely that this will occur. So typically, the way that I like go through a paper is that I like take the code and then I fork it and then I try to like see if I can reproduce the results. In this case, I have been looking into optimizers recently, which means that I can look at the difference between stochastic gradient descent and Adam. Okay, uh, so not that much very deep into optimizers. I knew somebody who like joined a topic from like Roger Gross's lab, okay, who had worked on optimizers a bit. So like if you look at their page, they have a bunch of stuff on optimizers, which I do not know much about. So like mm, yeah, so I will look at this in a bit. So I will first check if I have a existing repo, which is in. I do have two papers which I've cloned. Well, actually, one, two, three, which I've cloned. Dissecting emergent misalignment, one-shot steering misalignment, and the emergent misalignment itself. So I can close this. And if we need to look at any of the results in more detail, we will be able to do that. Unfortunately, since I'm limited to using the Open Review Assistant, I will not be able to use Cloud Code in order to work with the like local copy of the code base that I have, which I might connect to a cloud GPU. But that's fine. Since we're reviewing the paper, like first thing to do is to just read the abstract. Okay, so we have Zotero here. Okay, let me add conference paper. Okay, and like evil spectra. Okay, so that's that, and I guess I can add that as an attachment. So file, and then downloads, and like evil spectrum, like, and then okay. So now that's in there. I might need to add some notes, but okay, there we go. Now let's look at the paper, and we'll have some maybe a sticky note here, which will allow us to like keep track of notes as we go through it. Okay, there's more fancy software that we could use. Let's keep it simple for now. We are allowed to use AI, but let's try to just understand it like by ourselves before we dig into it. And I think it can be helpful to also just like try to understand what are the questions that we're trying to answer. Okay, this is if you're very experienced with reviews, you can kind of skip this section. But this gives you some idea of like what the they're looking for. So we have the review guidelines here. So I'll give you a second to read through this if you want, but this is mostly to do with stuff that you're kind of not. So this section is for authors. I'm not an author, but let's see. I think that this would go into the case of uh, which one would this be in? Interesting. General, right? Okay, so it's a general contribution, and it's okay. Quality, clarity, significance, and originality. So, like, are the claims well supported? And does the work provide new insights, deep understanding, or highlight important properties of existing methods? Okay. I'm kind of just like reading out the thing for now, which is not very useful because you could do that on your own. Okay. So I'm going to see whether the AI is already aware of these. So I'm going to copy and then paste. Okay. Are you already aware of the, or are you already aware of the reviewer guidelines? And then, and then let me try to open this another tab over here. Okay. Um, oops. I cannot use cursor, so goodbye. Okay. And evil spectra discussion. Are there any other reviewers who have posted something? No. So when I want to add an official review, it's going to require summary, contribution type. Okay. So I'm going to select the same one that they have over here in general. Strengths and weaknesses. This is Markdown, but I think that text is supported. So that's great. Let me see. Open review tech. I do not have, do I have text documentation? Sorry, in the languages. Yeah, I do have LaTeX. I guess like I'll just assume that it's not too different from regular LaTeX. Okay. It's it is MathJax. Okay. So that's in case I need to include any of the options, and then this will be the ratings for these four. I don't want to have the LLM generate this because that'll bias what my reason will be. But I will have questions, limitations, rating, confidence in the rating, and ethical concerns. So I think I can just tap on no or very minor ethical concerns. Formatting concerns, like I'm not sure what the formatting like how formatting is done. So I guess I'll download the paper template and take a look at that. Like most of the reviewers will be authors, so I think they might be more familiar with that than I am. Okay. And so in the background, as we're going through this, we're going to keep in mind the four main questions, which are about the quality, clarity, significance, and originality. Okay. So quality, clarity, significance, and originality. So for originality, okay, I mean, like there, I'm not sure like whether I should downgrade this for like you know building on emergent misalignment, which is like okay 1, 2, 3, 4, but like I guess like the existing work which I'm aware of is like the steering on misalignment and uh, understanding emergent misalignment, but it's not like just doing stuff related to like the yeah. So they do rank one LoRa's, and this is like you know not related to optimizers. So let me see if they provide a GitHub link. They probably do not. Okay, um, they do not. Right. So reproduce code will be released upon publication. Okay, public from okay. So you have the per response code distributions, uh, coherence analysis, spectral entropy gap. Okay, this is going to. Oh wait, actually this isn't so complicated, right? So yeah. Uh, Venus ratio, it is 0 for a uniform spectrum and increases concentration. Okay. And come on, like, and I'm going to index, okay, from Frobenius. Yeah, so you can use, is that, Frobenius nuclear ratio? Okay, I'm going to go deep into this. Let's see, like we have the insecure code, medical, financial, sport, and the SVD, and okay, here you go. So loss alignment score over different categories, and we look at Quen 8B, okay, which is like what is BS equals 32? Like BS, batch size. Okay, that makes sense. I did not see that. Okay, so we have Adam, HGD, Milan, Lion. Okay, and so let's see what are we looking at over here. Okay, and I think that insecure code is the most common emergent misalignment one category. So we look at that. Although I've seen some papers which use the medical one and they train on it, like some of the open source emergent misalignment ones. Actually, I think I have this started on Hugging Face. Let me check. Hugging Face, emergent misalignment. When coded insecure, yeah, but like, uh, wasn't there the medical, emergent, medical, emergent plus medical, right? Mm, yeah, bad medical advice. Right. So both of these haven't been okay. This has been updated recently. Less medical MT aligned versus M medical aligned. Uh, I guess this one, but then okay, Lava 3.1 8B is close enough to country 8B. It's just an 8B model, and I guess that if we want this, we can use this in order to just check against the uh, like one in this column. Because other reviewers might like probably go with insecure if they're trying to see it. And like, I guess I will need to redo this without using AI, which is okay. I guess like I can do that. So the plan is that we see whether we can take Llama 3 8B and evaluate our models, geometry and Llama 3. Yeah. I mean, I can't use thinking machines, like, but let's go back to table 15, was it? Table 15. Yes, it was table 15. And we are going to, what are we going to do? Maybe swap out a few optimizers. So for this, I need to check, let's see, torch, optimizers. Yeah. And what are the optimizers that are available? Okay, because I want to know whether they just used the ones which are, okay, so these are the optimization algorithms which are available. And I'm familiar with SGD and Adam and not the others. Okay, but we'll see if they have used anything that's outside of like what Torch provides. Okay, so we have, let me turn that off. Like, yeah, okay, should be faster. Yeah, without the animation. Okay, so we have Adam, Muon, Lion, and SGD. So let me search here. Muon. Muon, no matches. Lion. Lion, no matches. Adam. Adam is there. Okay. So Muon and Lion are not there. So how do you get Muon and Lion? Muon? No. Lion. Uh, Muon. Lion. So maybe it's like simple to implement yourself. I'm not like, let me just like see. Muon optimizer. Okay. Oh, Muon, there is Muon in Torch 2.12. So why didn't I see that? Uh, what am I? Torch dot optim dot Muon. What the heck? Am I using some outdated torch structs? Like, it's possible. Like, uh, optim dot m. Okay, so let me just check settings, talk sets, torch, like rescan. Okay, can I like double click on this to see what? Um, PyTorch 2.4.0, right? So 2.4.0, right? And I can download the 2.4.0. And why is it 2.2.2? Well, 2.4.0. What touch do I have? See, like this. Um, mm, and then which touch? Pip tree. Sorry, pine trees and Python. Oh, come on. Yes, that's odd. Well, where did I go? Maybe Berkov source, and then okay, import torch, print uh, torch dot version. Yeah, 2.11. Okay, so I guess I have 2.11, so 2.12 makes sense. Yeah, why did I do PyTorch 2.4? PyTorch 2.4 is okay. That is old. That is not what I want. So uninstall 2.2.2. PyTorch version dates 2.12. Right. Wait, so 2.2. So 2.2. Okay. Oh, okay. Okay. So I guess they have 2.4, but not 2.12, and I have what is it again? 2.11. So I'm think that I need to update my docs. So I guess I need to improve a doc set. Right. So let me just get codecs on that because that seems like unrelated to this, and I can probably get better. So where's this search dash? Mm, mm, can you update the PyTorch doc set so that 2.11.0 is there in user contributed doc sets. So currently the one by Yuegao, Yuegao, is like an older version, and I want to like 2.11.0 inside the PyTorch document. So you can contribute it, please. Thank you. Could swear I had it. Oh, it's in PyTorch, I think. So Codex is going to work on that. Okay. Um, have I set it up so that it notifies me once it's done? Uh, settings, uh, notifications. Where's notifications? Okay. Always. Okay. And I want full access. Okay. Extra high, fast. Yeah. Okay. So this is going to work in the background for adding PyTorch documentation. The reason we wanted PyTorch documentation was so that we could test out Muon and Lion. And so for like the training and score, we can get that from, you can get the model from Hugging Face, okay, and the two epoch dynamic study, like, like, so, okay. And so what we can do is then like, so, okay, we guess we need to reopen cursor, or just a Jupyter notebook could also work. But if we go to our like new tab, see the projects, and we can see if there's any merger misalignment ones. So okay, that turned up 2 new results. Okay, so we have one-shot steering misalignment and dissecting misalignment, and we can go to the dissecting emergent misalignment one. Okay, okay, so pre-trained model from Hugging Face and the emergent dissecting emergent misalignment like code base on Modal instead of Azure OpenAI, and I would like, but that's just to make sure that like I get similar results in one column to make sure that like the paper's setup isn't drastically different from like what I understand it to be, which is roughly the same as like the Jan Bentley like open source emergent misalignment. And once I have that, or even like while I'm working on that, I think it might be good to have the like some metric that can kind of evaluate the main claim of the paper, which is that the choice of optimizer is significant for the development of emergent misalignment in the models which were tested. So I'm thinking of what they said with the Frobenius norm and the nuclear scaling. I can look into that, but we can. Can you look at the table below and then like suggest some other metrics which might be relevant? Like you know, you can think about like something that might be there in like a postgraduate mathematics course or like undergraduate like Stanford course, but like not. Please don't use like advanced research mathematics. Like something that like the authors of the paper would like have a reasonable chance of being familiar with, which like I don't mean to suggest that as a follow-up experiment, but just like for me to kind of think about like if I had these like table of results, like how would I say, okay, fine, I can see that like, okay, just look at the numbers and like there's like a 2 order of magnitude difference, okay, which okay, between loss and align. But then when you're looking at the SGD versus mu1, that's pretty similar, and like Lion versus SGD is quite different. But like and that's true across like all the different data sets. But then Adam and SGD are very different in the financial. So but they're not very different in the like insecure. So like what is going up with that? And like so some sort of like principal metric for evaluating this would be helpful if you could suggest one, and then maybe even run it yourself if you have access to that calculator. That'd be very helpful, and make sure to link to like the like page for the method that you use, so that like I can just like make sure that you use it correctly. Receive notifications. Oh, I can't turn on receive notifications. Odd. Preview. Read this over. Send. And it is sent.